All right. Welcome to question 5. So in question 5, they say a bus is initially at rest on a horizontal frictionless table. If a force of 10 Newton acts on the bus for 3 seconds, what is the momentum of the bus at the end of the interval? So what you do, the first thing you do is to bring out your data. Any question you're solving under physics, please don't forget to do that so that you will know the formula you apply. So they say a bus is initially at rest on a horizontal frictionless table if a force of 10 Newton, that means they gave us force. What is the force? 10 Newton acts on the bus for 3 seconds. They gave us time. Give us time of 3 seconds. They say what is the momentum of the bus? That means we are looking for momentum. Let's call it P. So the first question you ask yourself, what can relate force, time, and momentum together? Can you still remember the second law of Newton? You know the second law of Newton, you have that F is equals to mass times acceleration. Can you still remember this? And you know that acceleration is velocity over time. That means any place I feel acceleration, I'll put it as velocity over time. I'll have it that force will not be m velocity all over what? Time. So if F is velocity over time, they gave us force, they gave us time. And recall that mass times velocity. What is mass times velocity? Momentum. Are you saying that? So any place I see mass times velocity, what am I going to put? Momentum. I will now have that F is equals to momentum over T. When they just make it the subject of the word formula, you have that momentum will not be equals to force times time. So momentum is equals to, did they give us force? Yes, 10. Did they give us time? Yes, 3. 10 times 3. What is 10 times 3? 30. The unit of force is in Newton. The unit of time is in seconds. So do we have anything like 30 in the option? Yes, option C. Question number 6. Question number 6, they said the change in momentum per seconds. Change in momentum per seconds is dash. Change in momentum per seconds is proportional to dash. A, mass. B, temperature. C, force. D, energy. Okay, now also recall that F is equal to mass times acceleration, and acceleration is change in velocity over time. That means F is equals to m, then change in velocity over time. What is m change in velocity? M change in velocity is change in momentum. So F is equals to change in momentum over time. So change in momentum per seconds is proportional to force. So the answer is force, which is option C. Now, number 7. Are you saying that these questions are not hard? It's something that you get angry and leave the hole for them. A train with an initial velocity of 20 meters per second, 20 meters per second, is subjected to a uniform deceleration of 2 meters per second. The time required to bring the train to a complete halt is dash. Okay, they say a train with an initial velocity. What is the initial velocity here? 20 meters per second is subjected to a uniform deceleration. So I have deceleration. Which is my final velocity. My deceleration. I have deceleration to be 2 meters per second. If it's decelerating, that means it is decreasing. That means I will have minus. You get that? Then they said the time required to bring the train, that means we are looking for the time. What is the time? We don't know. To a complete halt. Halt means to a complete stop. That means the final velocity is equal to what? 0. So what formula are you going to apply? You apply the first law of motion, which says that V is equals to U plus AT. V is equals to U plus AT, where V is the final velocity, U is the initial velocity. This A now is deceleration, and we are looking for time. So can we solve it now? So what is V? V here is 0. That is the final velocity. What is U? U is 20. Then plus, what is A? Remember that A here is acceleration, but it's deceleration. And what is deceleration? Minus. I have it as minus 2 times t. So that means plus minus is what? Minus. I have it as 0 is equals to 20 minus 2t. So what do you do? Minus 2t crossing the equality sign with b plus 2t is equals to 20. Make t the subject of the word formula. Divide by 2, divide by 2. These two cancel. I'll have that t is equals to 10 seconds. So do we have 10 seconds in the option? Yes, which is option B. Okay, number 8 question. Number 8 question. What did they say? Number 8 question. They said a car moves with an initial velocity of 25 meters per second and reaches a velocity of 45 meters per second. What is the acceleration of the car in 2 seconds? So it's very simple. So they say the car moves with an initial velocity. Initial velocity here, I have it as 25 meters per second and reaches a velocity. That means they reaches a final velocity of 45 meters per second. They say what is the acceleration? Acceleration is something we don't know. And the time of the car is 2 seconds. So what do? You have that v is equals to u plus at. Abi, what is v? Okay, since we are looking for acceleration, make it the subject of the formula. You have it as v minus u is equals to at. Divide all through by t. Divide all through by t. That means a is equals to v minus u over t. So I'll now have it that a is equals to what is v? Final, which is 45, minus u initial, which is 25, all over t, which is 2. 45 minus 25. 45 minus 25, I think is 20. Yes, 20. So our have that a is equals to 20 divided by 2. 2 here, 1, 2 here is 10. That means my acceleration is 10 meter per second square. Do we have 10 meter per second square in the option? Yes, option C. So question number 9. All right, question number 9. They said the velocity of a moving body can change either in magnitude or A, direction, B, value, C, unit, D, time. What is the correct answer there? Velocity, happy. So the velocity, is it a vector quantity or a scalar quantity? It's always a vector quantity. It change in magnitude and what? Direction. It has magnitude and have direction. So the correct answer there is option A. Option A is the correct answer there. Now, question number 10. They said a force applied to a rocket give it an upward acceleration equal to 2 times the acceleration of gravity. So we have acceleration that is equal to 2 times the acceleration due to gravity. The magnitude of the force is equal to A, the weight of the rocket, B, twice the weight of the rocket, C, thrice the weight of the rocket, D, 4 times the weight of the rocket. So how do you solve this? Okay, we have force, we have acceleration due to gravity. Okay, how do we do that? First of all, you should recall from the second law of Newton that F is equals to ma. F is equals to what? Ma. Now, they said from here, the force applied to a rocket gives it an upward acceleration equal to 2 times the acceleration due to gravity. That means the acceleration A is equals to 2 times the acceleration due to gravity. Do you get it now? They said the magnitude of the force is dash. So what happens is any place I see A, I'll put it as 2 times the acceleration due to gravity. I will now have that F is equals to N. What is A? Times 2 times the acceleration due to what? Gravity. If you should arrange it or rearrange this, what am I going to have? You have 2 times mg. That's what you're going to have. But can you recall that weight is equals to mg? Can you recall that? So if weight is equals to mg, that means any place I see mg, what am I going to put? Weight. That means the magnitude of this force is 2 times the weight. 2 times the weight. So do we have anyone that is 2 times the weight of the rocket? Yes. We have option A, the weight of the rocket. Option B, twice the weight of the rocket. So the correct answer is option B, which is twice the weight of the rocket. Question number 3. Question number 3. Question number 3. Question number 3. They said a car traveled a distance of d in 60 seconds and a distance of 2d in 120 seconds. So can you still remember? Okay, they said at 30 seconds the car has traveled a distance of 650 meters. What is the value of d? So how do we get the value of d? Okay, can you remember the speed? What is the formula for speed? Speed is distance over time, right? So speed is distance over time. That means the first speed, what is the first speed? I have that the first speed, because the car traveled a distance of d in 60 seconds. That means the first speed is d over 60, which is 60 seconds. That is distance over time, that is speed. And a distance of 2d in 120 seconds. That means the second speed that I'm going to have will now be 2d all over 120, according to the equation, all over 120. And they said at 30 seconds the car has traveled a distance of 650 meters. That means they gave us the speed of the third. The third speed, what am I going to have? The third speed, what is the distance? The distance is 650 all over, what is the time? 30. So 650 all over 30. Let's calculate it and see what, and know whether what it will give us. We have 650 divided by 30. So what do you have? I have it as 21.67 meter per second. So can I compare? I will have this as, can I compare the third and the second? If I compare the third and the second, I'll have it as 21.67 is equal to, which is the third speed, is equal to the second speed. What is the second speed? 2d all over 120. Okay, 2 here is 1, 2 here is what? What is the 2 here? I think it's 60. That means what I'm going to have is 21.67 is equals to d all over 60. And what is d all over 60? That is the first speed, which is equals to v1, right? So we are looking for d. Make d the subject of the formula. So I have that d will now be 21.67 times 60. So 21.67 times 60. What am I going to have? I have that d is equals to 1,300 meter. Do you have anything like 1,300 meter in the option? Okay, yes, option D. We have 1,300. So in this question, what you will do is calculate the first speed, second speed, third speed. Third speed, they gave us the value of the third speed. Equate it with the second and analyze it. You will get the distance that is traveled. So the last one, which is number 12. Number 12. Let's say number 12 question. It said the magnitude x covered by a body in t seconds is given by x is equals to 12t squared minus t raised to power 3. The acceleration of the particle in 5 seconds is that. So they gave us a displacement of a body and they asked us to calculate for acceleration. So if they give us displacement and ask us to calculate for acceleration, that means we are going to differentiate twice.